Hello everybody, my name is Mridul and today we are going to talk about the topic which is analysis of autotransformer. Now this topic is very important with respect to gate. If you see the last 4 years, the trend of the last 4 years in gate, in 2015, 2014, 2016 and 17 as well, there are questions from this topic from at least for 2 marks. Okay, so that makes this topic very important. Now in this topic, I'm going to concentrate on the area which is important only with respect to gate. Okay, so first of all, what is this autotransformer? Now before I start this topic, I will expect that whoever is watching this video, the prerequisite is to know the working principle of a transformer. Okay, the basics of the transformer. I'm expecting that you will be knowing the basics of transformer. So now, what is the difference between a transformer, a simple transformer and an auto transformer? There is a difference in the connection. Okay, so the application of this auto transformer is wherever the isolation is not required. Okay, the main difference is isolation. In this auto transformer, there is no isolation between the input and output, or the primary and the secondary. Okay, so the number of turns in the primary as well as in the secondary are made from a single winding. Okay, or in other words, they are connected. Whereas in two-winding transformer, if I draw it, the equivalent circuit of a two-winding transformer will be something in this way. Say this is coil 1, say this is coil 2, this is A, this is B, say this is end C, and let us say this is D. Now if I want to make this two-winding transformer act as a auto transformer, what I will do is I will connect these 2 points. So this is one way of making a two-winding transformer act as a auto transformer. Also, I can make a auto transformer by having a core in this way, and I'll have some winding in this way, and I'll have a tapping here, and I'll make a common point here. This is my common point for primary and secondary. So this is my primary windings. Say this has N1 turns and this has N2 turns. Suppose the voltage here is, suppose, say V1, and this voltage is V2. So this is a practical auto transformer, equivalent circuit of a practical auto transformer. I can also make a auto transformer from a two-winding transformer by connecting this 2 terminals. Okay. Now the thing is, why will I go for an auto transformer? What is the reason? So there are some advantages which we have to understand. First of all, we will only see the main thing is we will go for auto transformer if the isolation is not very important. But even if the isolation is not important, what are the other points where we will go for an auto transformer but not for a two-winding transformer? The most important point is the kVA rating. The example is, suppose I have a two-winding transformer and it is something like this, and this two-winding transformer has a rating of 50 kVA. 50 kVA. That means, let us say I have this side, the primary side, with say 2000 volts, and the secondary side has 200 volts. Let us say it is a step up. So if I keep 200 here and let us say 2000 here. So if I have a voltage, input voltage of 200 here, what will be the current here? The current here will be 50 kVA, that means 1000 divided by 200 250. So that means I'll have 250 ampere current rating of coil 1. Similarly here, the same thing, I have 2000 volts output here. So that means 50 divided by 2000, I will have 25 amp current in this coil 2. So the rating of coil 1 is 250 ampere, the rating of coil 2 is 25 ampere. Now this is a two-winding transformer which is working, or whose output rating is 50 kVA. Now the benefit or the advantage, the most important advantage of auto transformer is, if I connect and make it a auto transformer, if I connect it in this way and I make it a auto transformer, what happens is, now instead of 550 kVA, this same transformer, the same setting, after making this physical connection of this point B and C, the same setting will be working on 11 times higher. It may work of 11 times higher. That means the rating of this auto transformer will be maybe, I can have different connections, I can make different possible connections. So the maximum kVA for this setting is 550 kVA. How it happens we will see later, but for now, for the information I am saying that the kVA, you see, a two-winding transformer was having 50 kVA, whereas just a connection and making it an auto transformer, I am having a kVA of 550 kVA. That means the kVA has drastically improved or increased, okay, which is a very, very big advantage. So with the same rating, I am getting a bigger output, okay. So this is advantage of of cost, okay, and advantage of I don't have to have a more bulky or costlier conductors as well as core, okay. So this is one of the important advantage which is concentrated in gate. So whatever questions will come in gate will be something like this. They will give you a two-winding transformer and they will ask you what may be the maximum kVA rating of the auto transformer that can be achieved. That is one type of question they may ask. They may also give you the voltage ratings, okay. They may give you this, if a 200 volt, 200 to 2000 volt two-winding transformer is changed to, say, I may change the voltage rating to 2200, 200 volt, or some other connections can also be made. So if I make the voltage input and output as this, what will be the kVA for this? So we will analyze those things later. The first thing what I want to tell you is that how this happens, how a 50 kVA two-winding transformer becomes a 550 kVA auto transformer, how it happens. The most important thing that we have to see here is that in two-winding transformer, when it is not connected as a auto transformer, what it happens is the energy is converted, it is just transformed. The power from primary to secondary is transformed through the magnetic core. Whereas in auto transformer, what happens in auto transformer, this is the equivalent circuit of the auto transformer. Here what happens is, this much part, I will show it by some other angle, so that, see this much part, which is, what is the voltage here? If you see, this much is voltage V1, this much is V2, so the voltage of this much part will be V1 minus V2. Okay, and let us say this current is I1 and this current is I2. Let us see. So what will happen, you see, this much volt amperes, that means what is the volt ampere here? V1 minus V2 multiplied by I1. Okay, this much volt ampere is getting transformed. Okay, whereas how much volt ampere is getting transformed here? If I have, say, V1, this is I1 and this is V1. So here in this two-winding transformer, the voltage or the volt ampere which is getting transformed is V1 I1. Whereas here the volt ampere which is getting transformed is V1 minus V2 into I1. But this is not the only thing which is getting transferred. There is one more thing which is transferred. The power is also transferred by conduction. So what I am saying is, in autotransformer, the power will get transferred by two ways. One is by transformer action, one is by conduction. Since it is physically connected, there will be conduction from this part to this part. Now, how much volt ampere will be conducted? We can get it by, this is my transform volt ampere. So total volt ampere which is transferred is V1 into I1. Since V1 into I1 is getting transformed into V2 into I2, and we know that in a transformer, since the losses will be negligible and the power factor of input and output, I can say that they are equal. So input power will be equal to output power, or in other words, input kVA will be equal to output kVA. That means out of this V1 I1, this much part is getting transferred by transformer action. So the rest of that part, that means V1 I1 minus this part, which is V1, if I multiply it, V1 I1 minus V2 I1, and then this will get cancelled, and you can see that V2 I1. So this part, V2 I1, is getting conducted. Okay? That means what I am saying is, in two-winding transformer, the power is transferred only by transformer action. Whereas in auto transformer, the power is transferred by transformer action as well as by conduction. So this is the reason why I am getting a higher kVA output in a auto transformer as compared to a two-winding transformer. Now, there is one more important point or one more important advantage of auto transformer, which is also equally important with respect to gate. That is, a auto transformer, suppose I have a two-winding transformer and I have connected it to a auto transformer. What will happen is, since now my output increases, my efficiency will also increase, because the losses has not changed, because the current rating and the voltage rating has not changed. The amount of voltage and current that I am getting at the input and output might change, but internally the current rating is not changed. Okay? So that is the reason the efficiency of auto transformer increases for the same two-winding transformer. Okay? And we will also see a gate question. Later we will see how gate questions are asked in this particular topics. So before we go, now let us understand how we will get different kVA ratings from a same two-winding transformer. So let us understand the rating part, which is very, very important with respect to gate. Okay? Okay, so suppose say there is a two-winding transformer. Let us take an example. Say this is a two-winding transformer. Okay, and let us say this is 50 kVA, and this is coil 1 and this is coil 2, and the dot convention is in this way. Now I hope you know what is dot convention. When I say dot convention, means this 2 point at any instant, since I will be giving AC voltages, so what will happen is after every half cycle the voltage is going to reverse. Okay, so at any instant, if at this point I have a induced EMF of this polarity, say this is E1, the induced EMF here will be of the same polarity E2. That is what it means by dot convention. That means these 2 points are having the same polarity. Now, the current is also linked with this dot convention. That means, in dot convention, if you see that if current is coming inside, that means in this way, from the dot in the primary, then in the secondary what will happen is at the same time, current will be going outside of this dot, which is very, very important concept, or very, very important, dot convention. And I will be using this dot convention to explain the current phenomena in the KVA autotransformer. Okay, to find out the KVA in autotransformer. So you see, let us say current I1, this having current I1, here I am having current I2. Okay, let us give some values also. So say this is 50 kVA. So here I have, say, 2000 volts. Let us take 2000 volts here, and let us take, say, 200 volts here. So what is happening to C1 is, let us say C1 is having a current. If we just subtract it, we will find out that current 1 or C1 will have a current of I1 is equal to 50 kVA divided by 2000. Okay, 50 kVA divided by 2000, it's 25. So directly we can write it as 25 amps. Similarly C2, okay, and V1 also, let us write V1, we know it is 2000 volts. Now C2, let us see, I2 will be, since 10 is less here, easily I can say that this will be 250 amps. Now let us say that I convert this particular connection to this particular two-winding transformer to a auto transformer. Now here is the thing, you see I have many options. How the options are, how many ends are here? Let us name these points. Let us say this is A point, this is B, let us say this is C, and this is D. So I have 4 points A, B, C, D. For making a auto transformer, I will be connecting any of these 2 points, and I will make 1 point as common. So you see, let us connect. So connect B and C. Before I connect it, I must tell you that the possible output voltage levels can be divided into 2 parts, which is I can connect them by additive polarity or I can connect them by subtractive polarity. So first of all, let us see how to connect them with additive polarity. When I say what is additive polarity, that means I will show you now. Suppose if I connect B and C, the output will be in such a way, that means this I have connected and this. Now say this is my A point, this is my B point, I have connected B with C, this is my C point, and this is my D point. Now what I have done is I have connected B and C and made D as common. Okay? So what will happen is, you see, this voltage is, which is my coil 1, this is my coil 1, this is my coil 2. And I know the dot conventions are, I have a dot here and I have a dot at this point C. So now let us say the secondary I am taking out from these 2 points. So what is my voltage in the input? What voltage I can apply? The C1 has a voltage rating of 2000 here, so it is 2000, and this is 200. So total that I will be getting here is 2200 volts. Why? Because you see, these polarities are same. Okay, so this is called additive polarity. Now the output points, you see, I can make the output points at here and I can get 200 volts output. That means the rating or the ratio here will be 2200 by 200 volts. Now this is one possible connection of additive polarity. Similarly, I may have one more option, which is if I make instead of D, second one, if I make instead of the A as common, if I make A as common, so the voltage that I will be getting in the secondary will be 2000 volts. This is also possible. So that means second option is 2200 2000 volts. So these are the two possible connections that I may get by additive polarity. Okay. Similarly, if let us see how we can get subtractive polarity. Now, when we will get subtractive polarity, it means what we will do is we will connect B with D, say. Okay. Let us connect B with D. Now this is subtractive polarity. So third subtractive polarity, if you see, these two are additive polarity. Now I am going to show. Suppose this is D. So the dot point is going to change. Okay. Now I am connecting B with D. So if this is D, this is C, and the dot is here. Now what will happen is, at any instant, the voltage here will be opposite to voltage here at any instant. If this is positive, this will be negative. If this is negative, this is. That means, if at any instant, if this is say 2000 here, this will be 200 in this way. That means the total that I can get here is 1800. 2000 minus 200. So the output that I can get, maximum output in subtractive polarity that I can get will be 1800 volts in one side. That means, let me write it here, in subtractive polarity one side I will be getting 1800, and the other side I may get 2000 or I may get a 200. If I connect these 2 points, I may get 200 here. So it is 1800 and 2000 or 1800 and 200. So see, there are 4 possible ways of connection which I can do from a 2-winding transformer to a auto transformer. Okay. Now the important thing is, if I connect in any of them, the kVA rating for each of these connections is different. And this is what we have to learn, because in gate the questions will be something like that. First question they may ask you that I have a 50 kVA transformer, 2-winding transformer. If I reconnect it to a auto transformer, what is the maximum kVA that can be achieved? So you need to know in which case. I have 4 cases, right? Let us say this is 3 and 4. So in this, out of these 4 cases, in which case will I have the maximum kVA? That is something which we will analyze now. Secondly, you may also get questions like, I have a 50 kVA 2000 by 200 volts 2-winding transformer, and I have made it say 2200 volt by 200 volt transformer. Then what is the kVA rating for this type of connection? So once they have given it in this way, you need to find out what is the connection. So we will take practical gate examples and we will try to solve. Now before I go that, there is one basic rule that we will apply, okay, to find out the kVA. Basic rule is, see, we have learned how to find out the voltage. Voltage finding is very simple. The thing that we have to see is, where is coil 1 and where is coil 2? And what will be the current in coil 1 and coil 2? The current in coil 1 and coil 2 will be same as the two-winding transformer. I am not going to change it. Okay? That means, this is coil 1, then current in coil 1 will always be 25 ampere. And the current in coil 2 will always be 250 ampere. That is not going to change. But what is going to change is direction. So, if I have, I'm just showing you the first case. Okay, let us take the first case, which is 2200 by 200. Okay, so here in this case my polarities are additive polarity, let us say. Okay, so what happens is, this is 2200 volt and here I take, say, 200 volt. This is my output. Now in this case, let us see how to find out the kVA rating. So kVA rating is nothing but input current into input voltage or output current into output voltage. Okay, that means, let us say this is I1 and let us say this is I2. So my kVA will be V1 I1 equal to V2 I2. So I can calculate any of them. So the calculation is simple, you see. Say this is C1. And in C1 I am saying that the maximum current that will be flowing is 25 ampere. That means this is 25 amps. So if this is 25 amps, so what will be my output? My output will be 2200 volt into 25 amp. This will give me my kVA. So if we calculate this, the value comes to be 55 kVA. Okay, this will be 55 kVA. Okay, now let us see what will happen, or let us just verify it by finding out V2 and I2. So V2 I2 should also be 55 kVA. Now how to find that out? So what I have said is, if C1 is 25, C2 should be 250 amps. So if C2 is 250 amps means, now you see, you have to see the polarity here. What I said again in the dot convention is, if current in primary is coming inside, if current in the primary is coming inside through the dot, what will happen to the current in secondary? It will come out. That means, if current is coming in this, at this instant current is coming inside, so at this instant current will be going out. So how much current will be going out? We know that the current that will be going out from C2 will be 250. So if this is 250 and this is 25, I can apply KCL here. That means current law. That means, say this is IC1 and IC2. So I can say that I2 will be IC1 plus IC2. See, this current is coming here, this current is coming here. So both of them together will come out through IC2. That means 250 plus 225, that means 275 amps. Okay. Now you see the output voltage V2 is 200. So V2 I2 will be 200 into 275. 200 into 275. So if you multiply 200 into 275, what you will go get is the same 55 kVA. Okay. So this is just for verification purpose. The simple way that you can find out is just multiply this voltage on the primary side with this current, which is on this for the coil C1. That means 2200 into 25, you will directly get your kVA rating. Once you get your kVA rating, it's done. Okay. Similarly, let us take one more example and see. one more example we can take and see. For example, now the second connection of KVA. That means in this way, suppose this is C1, I can do the C2 above also, and I can show the C1 in down also. That means I can do this way also. So do not get confused with the way of drawing. That means I can do it upside down also. That means, say this is C1 and this is C2 now. Okay, and C1 is having 2000. That means now this is my output and this is my dot convention. And here I am having 200 volt and here 2000. This is 2200. This is additional polarity if you can see here. And here since C1 is, I have given the C1 coil 1 and the down. So here I will get 2000 volts. Now I know current in C2 is 250, so the amount of current that will be flowing here will be 250. It is coming inside, so if current is coming inside in the primary, current will be going out through the secondary, so that means current will be going through this side. And what is the current that will be going? We know C1 is 25, so this current will be 25 amps. So 25 plus 250, again it will be 275. So 275 multiplied by 200, you see 2200 kVA rating will be 2200 into 250, which is similar to 275 into 2000, and which is equal to 550 kVA. That means 550 kVA. So this is CV1 I1 and this is V2 I2. Both of them will be equal, and in this case my kVA rating will be 550 kVA. Okay. Similarly, I can show you the kVA. So this is a maximum case, you see. Now if anybody asks you, okay, in gate questions also it is asked what is the maximum possible kVA rating. So maximum possible kVA rating, by common sense we can say that the maximum possible output voltage is by adding this 2000 by 200, which is 2200. And I will multiply this with the maximum possible current, which is, see, this is 25 ampere and this is 250 ampere. So what I will do is maximum possible voltage multiplied by maximum possible current, which is 250. If I multiply them, I get the maximum possible kVA. And this is a question of 2016, which we will see later. Okay. Now let me just show you one more example, which is for the subtractive case. So in subtractive case, what will happen is, in the subtractive case, let me redraw it again. Say this one is C1 and say this is C2, and say I have subtractive polarity, that means the dot will be in this way, opposite way. And this is, I know since it is C2, my output voltage will be 200. Here my input voltage will be 1800 volts. Now how to find the kVA? It's very simple, 1800, and I have C1 here. If I have C1 here, that means my current I1 will be 25 amps. So definitely by looking at only this part, I can say that V1 I1 is 1800 multiplied by 25. If I find, I think this will be 1800 into 25 will give me 45 kVA. Okay, 45 kVA. Please calculate and just recheck it. So it should be 45 kVA. Now suppose I need to verify it by finding out whether my V2 I2 is 45 or not. For that, let me apply the same principle, which is, what I am saying is, if 25 ampere current is coming inside through the dot point, so what will happen in the secondary? Current will come out of the coil. That means now current will come out means current will be in this direction, it will come out of this. This is coming inside the coil, so current will be going outside the coil. So outside the coil means through the dot. Okay, through the dot. Here current is coming inside through the dot. Here current is coming out side of the coil through the dot. So how much current should go out? We know the rating of this current is 250. So 250 current should go out through this dot, and I have 25 ampere coming, 250 going here. So how much current should be coming through here? Again, I will be applying KCL at this point. Let us say this point is AB, B point. At this point, if I apply KCL, I will see that definitely 250 minus 25 will give me 225 amp. So 225 amps of current will be my I2. This is my I2. So now V2 I know it is 200 multiplied by 225. Okay. So if you see again, this will become 45 kVA. Okay. So you see, this is how we can calculate. One more option also similarly you can do by yourself. I will not be doing that. Say it is 2000, that means I am keeping it C1 here and I will keep C2 here. So if I am keeping C1 here, C2 here, this will become 250, this will become 25. So you can calculate by yourself. Okay, what will be the current? It's very simple. It will become, this point will again become 225. That means now the direction will be in this way. Okay, and this will become 250. So in this case, you can see that the output kVA will be 450 kVA. So these are the four cases where we have got four different kVAs, that is 55 kVA, 550 kVA, 45 kVA for 450 kVA. So out of them, we have seen that in the four possible connections, the most or the maximum kVA that we got is 550 kVA. And the case, which case was that? That is very simple. That is maximum voltage which can be achieved multiplied by the maximum current in the coil. Okay. Okay, let us see some gate questions. How are the gate questions? So in your PPT, you can see a 2009 question. Okay. In this question, it is said that the figure above shows coil 1 and coil 2 with dot markings as shown. Okay. Having 4000 and 6000 turns respectively. So what is said in this particular example is, I have coil 1 and coil 2. It is similarly in this way. And what else they are saying is, having 4000 and 6000 turns. That means N1 here is 4000 and N2 here is 6000. Okay. Both coils have a rated current of 25 amperes. That means C1 and C2 both have 25 amperes. Both of them have 25 amperes. Okay. And coil 1 is excited with 400 volts. That means the input here is 400. So we know N1 by N2 is 4 by 6 or 2 by 3. So if, or in other words, if this is, if I have a V1 with 400, so definitely my output from here I can say that in this two winding the output will be 600 volts. Okay, so this is the information that is given. Now the next page I can see that first question is, the coils are to be connected to obtain a single phase 400 by 1000. 400 by 1000 autotransformer to drive a load of 10 kVA. So they are driving a load of 10 kVA for that. Which of the options should be exercised to realize the required auto transformer. Okay? So let us see how this can be achieved. So you see 400, that means in the primary I will be having something like that. Say, I can connect it in this way. So I can make, this is C1 is having 400 volts, so I will keep C1 here and C2 here, let us say. And you see in the secondary, I am having 1000. 1000 means 400 plus 600. That means it should be additive polarity. That means the polarity of the dot markings I can give it in this way. So here I can say that my output is having 1000 volts and input will be 400 volts. Now they are saying that the output is 10 kV. Okay? The output is 10 kVA. That means what is I1 I can find out and what is I2 I can find out. So let us find out I1 and I2. So I1 will be 10,000 divided by V1, which is 400, 425. That means 25 amperes will be here. And what is I2? I can similarly I can find out I2 will be 10,000 divided by 1000. So this is 10 amps, very simple. Okay. Now you see, they are saying that coil C2, the maximum current that C2 can flow is 25 ampere. But see, this is given as 10 kVA. That means this auto transformer is not working at its maximum level. It is working at a kVA which is lesser than its higher. kVA rating means if I have a transformer and if I say that particular transformer has a kVA rating of say 555 kVA, that means the highest rating should be 55. I should not give more input voltage or current to that. Okay. So here in this case, the kVA output is 10. It may work more than this also. Okay, but it is working at 10 for now. So let us say that current is say coming out from this C2. So current should go inside this C1. So current should go inside this. Okay. So if current goes inside this, what will be the current in C2? C2 I can definitely say that C2 will have 10 ampere and C1 will be having, see 25 ampere is coming in this side and 10 ampere is going this side. So 25 minus 10, 15 ampere is coming through C1 by kV. Also, what are the points that I have joined? I have joined, what are the, see, in this question, let us see what are the options that are given. Option is connect A, D and make B common. What I have done here is, I have connected A to D and I have made, so this is my C point, I will mark it. What I have done is C and this is D and I have connected A and this is B. So I have connected A and D and I have made B. So this is exactly what I have done. And to get this rating I have to do this. So you can see that in this first question the option A is correct, which is connecting A and D and making B as common. Okay, B as common means B will be common for both primary and secondary. Second question in this same second part of this question is, in this auto transformer the current in each coil. You see, we have already calculated the current in the each coil. So I can say that C1 will have 15 ampere and C2 will have 10 ampere. So you see, out of these options, the D option is correct, which is coil 1 is having 15 ampere and coil 2 is having 10 ampere. So you see, the question is done, and if you can just do this, you will be awarded 4 marks. So this is a 4 marks question. Okay. Nowadays, in fact, there are these common data questions are not there. Even though common data questions are not there, you see in the recent questions, if you see, say, let us take an example of 2016 question, you will be at least having 2 marks question, and in this question it is asked that a single phase 2 kVA 10 volt by 200 volt transformer is connected as an auto transformer such that its kVA rating is maximum. The new kVA rating. Now they are asking what is the maximum kVA rating possible for the given connection. So I have already told you in which case we will be having maximum kVA rating. So in this case, in this particular question, the question is 100 by 200. Okay, and this is 2 kVA. That means, let us say this is 100, this is 200, say this is C1, this is C2, and it is 2 kVA, that means 2000 volt ampere. So if this is 2000 volt ampere, I can easily say that C1 is having 20 amps and C1 will be having 10 amps. So the current C1 is having 20 and C2 is having 10. So what is the maximum current? So coil C1 is having maximum current, which is 20 ampere. And what is the maximum voltage that I can get? The maximum voltage that I can get is in additive polarity case, that is 200 plus 100, that is 300 volt. So the maximum kVA rating will be 300 volt multiplied by 20 amps, which is 3 to the 6 kVA. Okay, so the answer will be 6 kVA, and the range of this question is given is 5.9 to 6.1 kVA. This is the answer that is given by the gate. And so you see, by our calculation we got 6 kVA, which is inside this range. So our answer will be good. Okay, so this is very simple, and if you do this, you are getting 2 marks. Okay. Similarly, let us see some other questions. Let us say one more question of a different set of 2016. In this question, it is said that a single phase 22 kVA 2200 volt by 220 volt distribution transformer is to be connected as an auto transformer to get an output voltage of 2420 volt. Its maximum kVA rating as an auto transformer. Now in this case, you see, this is also a typical case where they have fixed one side voltage. Okay, they have fixed one side voltage. That means they are saying that I have a 2-winding transformer of 2200 and 200, right? Or 220, 220 volt. So this is the condition, and let us calculate the maximum current these coils can carry. I1 will be 22 kVA. So the rating is given as 22 kVA. So 22,000 divided by 22, it is just 10 amperes. Current of C1. So C1 will be having 10 amps. C2 can have 100 amps. So C2 can have maximum 100 amps. The rating is this much. So I will connect this 2-winding transformer as an auto transformer, and see the output is given as 2420. That means, you see, what is the maximum voltage that can be here? If I add 2200 with 220, so I will be getting 2420. That means this is additive polarity. As simple as that. This is additive polarity. That means this is C1 and this is C2. and the voltage here is 2420. Now they are asking what is the maximum kVA that I can get. You see the secondary side voltage is not given in this question. You see this is C1 is 2200 and C2 is 220. Now I have two options here. That means I can take my primary or secondary as this one, or I can take my secondary as this one. So now I should know that in which case I will get maximum current. You see, that is easy to calculate. If I connect, let us say, if I connect it in this way, so what will happen is, I will have I1 as 10 ampere. Okay? So my kVA will be this multiplied by this, which is 24200. That means 24.2 kVA, which is one of the option, which is a B option, which is 24.2. But I have to see what is the kVA that I can achieve with the other connection, which is, so first option which I got is 24.2 kVA. Let us see what if I connect this as my output. So if I connect this as my output, now what is my current I1? Let us see. So say, now this is C1, so maximum current that can come inside, or let us say current that will be coming inside through here will be 10. So if current comes inside here, the current will be going out through here. The current that will be going out through here will be 100. So if this current is going out, that means you see the path is very simple. So you see 100 current is going through here. So from where it is coming? It is coming from here, which is this. This is I1. Okay? This is I1. So you see this is I1 means in this way it will happen. So 100 ampere current will go here. Okay? 90 ampere current will come out from this side. Okay? And 10 ampere will be coming, 100 ampere current is coming from here. 10 ampere current is coming from here. So 110 ampere is going out here in this way. So 110 is coming here, 10 is going here. So I1 from this KCL at this point, if 110 minus 10 will be 100. Or directly you can say that this here, if 100 ampere is coming, this is my I1, which is 100 amps. So I can directly multiply. So in this case, see, I will get 242 kVA. So in one case I got 24.2 kVA, in the other case I got 242 kVA. So out of this I can easily say that the second one is a higher kVA, or this is a maximum kVA that is possible for this connection. Okay, so the answer will be C, not B. So if you go for B, the answer will be wrong. Okay, so these are the typical examples or the possible questions that may come from this two-winding transformer, or perhaps the auto-transformer questions related to two-winding transformer. Now, I will just show one more example, which is a indirect question. That means using this particular concept, they will ask something else. That means they may ask you efficiency and all. Now, I have said that efficiency of two-winding transformer is less than a auto transformer. That means if I connect an auto transformer from a two-winding transformer, my efficiency increases. Now let us take an example or a question from 2007, where I will just show how they may ask you a question related to efficiency from the same concept. So in this question, which is in your PPT, you can see that it says that a single phase 50 kVA 250 by 500 volts. That means I have a two-winding transformer, and this is 250 and this is 500 volts. Two-winding transformer has an efficiency. Here the efficiency is given as 95% for the two-winding transformer. And this efficiency is at full load and unity power factor. Full load means the current is carrying, the rated current is flowing, okay, and unity power factor. Okay, so from here what we can do is, we know what is efficiency. Efficiency is output kVA multiplied by power factor, okay, and percentage loading, which is X percentage loading, divided by same thing X percentage loading into output kVA into power factor, okay, plus losses. Okay, the losses will have copper loss as well as iron loss, and iron loss is a constant loss, whereas copper loss depends on the current rating. Okay, here since it is a full load rating, so I am taking that as PL. Okay, so PL will, that means is a copper loss plus iron loss. So here you see X is given as 1, output kVA is given as, it's given in the question, right? It's 50 kVA. So output kVA is given as 50 kVA. So 50 kVA multiplied by power factor is also given as 1, unity power factor. So by 50 kVA plus PL, the efficiency is given as 95%. From here I can find out what is PL. Okay. Now it is said that this particular construction is reconfigured as a auto transformer with 500 volt and 750 volt auto transformer. That means how to connect this 500 and 750. That means definitely I have added this in one side. Okay, this is additive polarity. So 500, say this is C1 and this is C2. So let me first of all find out, if I calculate the PL here, yeah, if I calculate the PL, I'll find that it is 2.63 kV or kilowatt, we can say. Very good. So power loss is 2.63 kilowatt. So let me write it down somewhere. Let me reconfigure it again. So from two-winding transformer we have calculated the PL loss, which is 2.63 kilowatt. Okay. Now let me reconfigure the auto transformer, and before that let me calculate 50 kVA. This is 50 kVA. So if this is 50 kVA, what will be current in C1? In C1 the I1 will be 50,000 divided by 250, so 25, 2, so it will be 200 amps. So C1 will be having 200 amps. And I2 will be having maximum 500 divided, that means 100 amps. So the power that we got here is 2.63 kilowatt. This is the power loss. Okay. Now let us reconfigure this again. So it is said that it is reconfigured as an auto transformer by 500 and 750. So 500 on the left hand side or the primary side, that means C2 on this side. So let us say I have C2 here and C1, let us keep the C1 above, and see the voltage is 500 by 750. So 750 means, you see 500 plus 250, that means this is an additional polarity. So I will add this to voltage. That means this is C2 and this is C1. Okay. Now this is 500 volt and this is 750. volt. So current in C1, I know. Now you see, they're asking to find out the efficiency for the new rated load. Now rated load means my coils will be carrying rated current. So rated current of C1 I know is 200 amps. So let us say this is 200 amps. 200 amps is coming out of this dot. So if current is coming out of this dot, what will happen here in this dot? Current will be coming inside. So current will come inside here. How much current will come? I know C2 is 100. So 100 amperes will be coming inside. So what will be the current that is flowing here? So this should be 300. From the point KCL applied at this point, I can find out easily that current will be 300. So you see my kVA rating will be 500 multiplied by 300, which is 15 kVA. Also I can find out from here also, my kVA is 200 multiplied by 750, which will also give me 15 kVA. Okay. Now let us see what is the kVA, 15 kVA. So what we need to find is, we need to find out the efficiency. So how to find out the efficiency? Also it is given that we have to find out the efficiency at the unity power factor. So unity power factor means, you see, so now we have the kVA as 15 kVA, power factor is unity. So what will be the efficiency now? And it's at rated load. So output 15 kVA multiplied by 1 and rated load, so 1. Okay. Also 15 here plus, now copper loss and iron loss, as I have discussed earlier, that since I have reconfigured this two-winding transformer as a auto transformer, so what will happen is the losses are not going to change. Since the current rating in the coil is not increasing. The current rating in the coil, which was earlier 250 in C1 and 500, sorry, in C1 it was 200 and C2 it was 100. So after reconfiguring in auto transformer, even though we are getting the same current in both the coils, the output kVA is changing. Okay, but the currents in the coil inside the auto transformer are not changing. That is the reason the copper loss will not change. Similarly, the iron loss will also not change. Okay, since we are using the same core, so iron loss and copper loss will be same, which we have already calculated, which is 2.63. So 2.63, both of them in kilo. So this kilo and this kilo gone. So it will be 15 by 17.63, and if you calculate this, it will become 98.276%. Okay, and the option will be option C. So you see, earlier this two-winding transformer was having a efficiency of 95%. Now it has increased to 98.276%. So this is the advantage that I was telling about, where the efficiency will be increasing if I reconfigure a two-winding transformer into a auto transformer. Okay. So with this, I will conclude this particular topic, and I hope I have explained it I have made it easier for you guys, and I have concentrated only the topic which is important with respect to gate. So I hope this is helpful for you. Thank you.